Number 5, let R be the shaded region bounded by the graphs of y equals x e to the x squared, the line y equals negative 2x, and the vertical line x equals 1 as shown in the figure above. Part A, find the area of R. To get the area, it's just going to be the integral from an x value to an x value, and then we will be doing top minus bottom. So if we do this to get the area, we will take the integral from 0 to 1, because this shape is going from 0 to 1, and then it's going to be the top. The top curve is going to, the one that's a curve, which will be x e to the x squared, minus the bottom curve, which would be negative 2x. So that's going to be the setup, and since there's a plus sign, we can just take the integral of each one of these separate, and I'm just going to actually write them separately. X e to the x squared plus the integral from 0 to 1 of 2x. That will make it a little bit easier, I think. Okay, in this first integral, since we have one e in the problem, we'll let u be our exponent, so we'll let u equal x squared, which means du is going to equal 2x dx. I'm missing the 2, so 1/2 goes on the outside, so this now becomes 1/2 the integral of e to the u, and the integral, I'm going to put my answers over here now to help me out. My integral is going to be 1/2 e to the u, which is x squared. So that part's done. We're going to evaluate that at 0 and 1. And then plus, let's find this one. The integral of 2x will just be x squared. And again, I'm going to evaluate that one at 0 and 1. So if I do that, if I plug 1 in here, I'm going to have 1/2 e, 1 squared is just 1, so it's just 1/2 e, minus 1/2 e to the 0, and e to the 0 is just 1. So on this part, I'm going to have 1/2 e minus 1/2, and then plus, so that's that part. This part's going to be, if I plug in 1, I'll get 1, minus if I plug in 0, I'll get 0. So this will be plus 1. And if I do that, okay, I'm doing fine here, I'll get 1/2 e, and then negative 1/2 plus 1 is, excuse me, 1/2. All right, this would be a fine answer. If you'd like to as well, you could factor out the 1/2, and that would be okay as well. This problem was worth 3 points, and usually on these area volume problems, if there are 3 parts, each part is worth 3 points. So to get, first of all, there's 1 point for setting up this first integral. There is 1 point for properly taking the integral, and then there's 1 point for getting the right answer. Okay, part B, write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals negative 2. So y equals negative 2 is somewhere down here. This is a horizontal axis of revolution, so we are going to be using the washer method. And if you recall, the washer's volume equals pi, an x value to an x value, so it will go 0 to 1. The outer radius squared minus the inner radius squared. If I look at this, if I were to draw a line, and I put dots on the line, whichever dot is furthest away from the axis of revolution, that's going to be our outer radius, and I notice that it's that curve, so it's going to be x e to the x squared. But please remember that if I'm revolving something other than the x-axis, I have to move this line to the axis, so I'm going to have to move it up too. So I need to move both of these shapes up too. So that's going to be my first one. And then minus the inner radius squared is going to be the one that's closest. So it's just going to be this line. So it's going to be negative 2x. Again, we'll have to add 2 to it because we have to move everything up 2, so that line gets moved up to the x-axis. And that will also be squared. And then this whole thing dx. And this one we have to be really careful on because we don't have our calculator to save us. If we get a negative answer, we can just switch these around. We just have to know right away. So that is the setup. We are going to get 3 points for this problem, 2 for the proper integral setup. So I would suggest just subtracting a point, maybe if you forgot your squares or if you had them backwards, you forgot your plus 2 but everything else was right, and we'd be good. And then your other point is going to come from if you put pi and 0 and 1. So if you have all of that sitting in your problem, that would be worth a point. Alrighty, part C. Write, but do not evaluate, an expression involving one or more integrals that gives the perimeter of R. So this would be a BC topic for sure. Perimeter is just adding up all the way around the figure. So we're pretty much just going to add up all 3 sides. So I'm going to call this 1, 2, and 3. All right, and it will write an integral expression. So I'm going to find each one of those and then I'll just add them together. So to get 1, to get the length of that, we're going to use the arc length formula. And if you can recall, the arc length formula is a to b the square root of 1 plus f prime of x squared. So that's the formula we're going to be using for this one. So it's going to go from, this one does go from an x value of 0 to an x value of 1. So 0 to 1. And then it's going to be the square root of 1 plus the derivative of negative 2x. So that will just be negative 2 squared dx. And then, let's see, this will come up to be 0 to 1 of the square root of 5 dx, and I'm just going to keep working this one. The integral of the square root of 5 is just going to be the square root of 5x. I'm going to evaluate it at 1 and 0, and when I do that, I will end up getting the square root of 5. So that's the length for that one. For number 2, we've got a curve going on, so this one, same formula, 0 to 1, square root of 1 plus. Now we need to take the derivative of this, and when I take the derivative of this, we will have to use the product rule. So this is f, this is g. F prime will equal 1, and then g prime, the derivative of e to the x squared will be 2x e to the x squared. So my derivative is going to be f prime times g, so e to the x squared plus f times g prime. X times 2x is going to be 2x squared e to the x squared. And then that whole thing is squared, and then we've got dx. And it does say that we do not need, we're just writing in the expression, so we don't need to try to evaluate that, so I'm just going to leave that one like it is. And then the third one, since this is just a vertical distance, we can just take the y value up here and subtract the y value down there, and that will give me my length for that one. So the y value up here, it's on the curve x e to the x squared, so if I plug in 1 into, if I plug 1 into that formula, it's going to be 1 times e to the 1, so that will be e. And then down below, if I have negative 2x, if I plug 1 into it, I'll get negative 2. So this is 1e, and this point is 1, negative 2. And so to find the distance, I just subtract the y value, so it's going to be e minus negative 2, so that will equal e plus 2. All right, so the perimeter of R is just all three of those added together, and it did just say to write an expression, so I'm going to. I'm going to have the integral from 0 to 1 of the square root of 1 plus e to the x squared plus 2x squared e to the x squared squared dx plus the square root of 5 plus e plus 2. And obviously you can write that in any order that you would like to, but that's that. That's worth 3 points. All right, first of all, you're going to get a point just for finding properly this derivative right here. So that was worth a point. If you have the integral correct for that one, that would be worth a point. And then if you were able to put them all three together, that was worth another point.